can. Hello, everyone. Welcome. Good evening. My name is Dalia, and I'm part of Elastic's community team. Today, we're here to hear from Mihalis, and he's going to talk to us about how the Elastic stacks.
Okay, Talia, thank you very much for the introduction. Hopefully it was just me, but you were breaking up a bit. So hello everyone from me as well. I am Halis, data engineer and team leader at Agroknow, and we're here today to talk about food safety risks, how we handle them, and how we are utilizing the Elastic Stack, and it's helping us make our work better. So let's start with some background. Now, who are we? Who is Agroknow? And Agroknow is a food safety intelligence company that collects, translates, and enriches global food safety data. And this is our tagline. And hopefully, this should be super clear to everyone, right? Okay, hopefully, it's not super clear to everyone because then the rest of the slide will have no meaning. So let's attempt to identify the core things that we do within Agroknow. And the core things that we do within Agroknow can be identified by this pink box here. We collect, we translate and enrich, and what we do this upon is food safety data. So let's take it one step at a time and try to break through and break down what we're actually doing and how we're doing this and how Elasticsearch is helping us do this. Being a data engineer myself, there is no other place to start but start by on the data. And what we're doing is that we handle food safety data. But let's talk a bit about food safety. Now, what is this term and what does this have to do? Now, food is recalled every day. Throughout the world, there are food safety authorities, official organizations that recall, that take back from the market and from the shelves of the supermarkets unsafe products, say products that are not safe for the end consumer to actually consume. And here you can see a quick list of the food safety authorities out there. Pretty much every country in the world has one, at least one actually. Within the US, for instance, there are two distinct organizations for this. And you can see here a quick list of the sources that we currently within Agroknow keep track of. These are sources that announce food safety recalls on a daily basis. Just to give you a quick overview as far as numbers are concerned, so far within 2020, we have roughly 22,000 recalls, and this is only within 2020. So you can understand the vast amount of data that is announced on a daily basis out there. Okay, so we've identified the data, we've talked about food safety data. Now let's move on to actually collect this data. So the next step would be to collect them. And just to give you a quick overview, this is a quick example actually from one of the sources within the United States. You can see on the image on the left, this is the list of the latest food safety recalls that have taken place. And on the image on the right, if you click on any of these links, you can see the actual detailed information. And this is something we want to collect. This is something we want to grab, to crawl, and to process in the future. So I'm guessing that you're all thinking that, okay, web crawling is easy, it's been done a number of times, it's quite a straightforward procedure. You have identified your sources, so what's the tricky thing here? And the tricky thing is the various data formats that are out there. Most of the sources, of course, have HTML data. These are web pages. They list the recalls on a specific web page. Then you can, you know, get specific patterns out of the calls and collect them all. But you have also PDF files or RSS feeds or XML feeds and Excel spreadsheets, for instance. So okay, we've identified our sources, we've taken a look as far as the different data types are concerned. Okay, we've done pretty much the whole work, so it's time to actually collect the data. And this is the first part of Agronow's data platform that we would like to show you. As you can see here, we have a layer, the initial crawling layer. Now, this is the layer of our crawlers, our web scrapers that are collecting this kind of data. They are constantly tracking this source of information and they're inputting it over to the rest of the data platform. And as far as technology is concerned, these web crawlers, these are mostly Java. This is mostly a Java web crawler. However, we're currently experimenting with scraping. And okay, this layer actually gets a hold of the data. What's the next step there? We have to store it somewhere. And there we have our raw data persistence layer. It kind of consists of a MongoDB database. We have throughout our data platform, as you will see, we have employed the microservice architecture. So we have a wrapper API on top. So the chronic layer gets the data, sends them over to MongoDB, and there is another layer, another project. It's actually split between Java and Python at its current state that actually gets this data and transforms them. And what we mean by transform is that each data source actually has a variety of different formats, different properties, and what we want at this step is to actually transform it into a unified bundle. We want to harmonize it and let it follow our internal schema. Just to give you again a quick overview of this, as far as food safety recalls are concerned, so far in our data platform, and this is data going back to 1918, we have collected 680,000 food recalls throughout these roughly 40 years. Okay, so we have collected our data and it's time to move on to the next step. We have to enrich it, we have to translate and enrich it. And what we mean by this, in order to answer this question, we need to pay a closer look at our data and try to identify what exactly is important within a recall. So let's have a quick look at the important properties of a food recall as far as Agroknow is concerned. And the first thing that we want to identify in this raw data that we collect, let me just remind at this stage that they may be HTML files or PDF files, XLS, and so on. So the first important property is actually the ingredient. So which was the main ingredient that was recalled? Just to give you an example here, on the left we have um, a food recall that was announced by the official authority within the United States, and you can see annotated with this yellow annotation the actual main ingredient. These are hamburger buns that were recalled, and now our goal is to actually try to identify this. And this is, by the way, an HTML page, so we have to get the HTML data and try to identify which is the ingredient. And the way we're doing this is that we've actually integrated within our system two distinct kinds of information. The first one, the image in the middle, shows a quick overview as far as our product taxonomy or vocabulary is concerned. So we have created a hierarchical vocabulary that covers all of the ingredients covered in these food recalls. This is a hierarchical model, and you can see here highlighted the specific ingredient that we want to annotate this recall with. And on the image on the far right, we've also you can see a quick overview of the data available on Wikipedia. And what we want to show at this step is that we're also utilizing open data out there. So you can imagine that the Wikipedia plays a role because throughout our vocabulary there are also alternative names, other names each term may appear as, or multilingual names, and so on. Okay, so this is the first important property. The second one is the reason of the recall. Why was the specific ingredient recalled? What went wrong? Again, going back to our example, you can see here annotated with the green annotation the reason behind the recall. And the reason behind the recall is actually that there was found small pieces of plastic within these hamburger buns. And how we are able to identify this? Similarly to what we did with the ingredient, we've also created a similar vocabulary for hazards, for reasons behind its recalls. Again, this is a hierarchical model, and you can see here a quick overview as far as plastic fragment is concerned. So, okay, we have identified the ingredient recall, we have identified the reason behind the recall. Now it's time to identify which was the company or the companies that were involved in the recall. Again, we're moving back to our example and you can see it highlighted in blue here. Now, how are we able to identify this? The way we do this is that we employ NER techniques, named entity recognition techniques. And this way we can identify terms that are most probably companies or organizations. And again, the image on the right actually shows a quick graph overview. This is a screenshot from our Neo4j instance that if we have this kind of connections and we know the recall, we know the companies involved in it, we know the ingredients and the hazard, we can perform this kind of graph analysis and we can actually identify relationships that exist within our data that were possibly hidden or straightforward out there, but this is kind of a useful information that we can identify if we find out these properties. Okay, we know about the company, but what was the specific product brand? For what should the end consumers look out? Again, similar to what we did before, you can see it here highlighted in orange. We're able to identify the product brand, and how are we able to do this? Thankfully, there are open sources of information out there. You can see here a quick overview of the kind of info that we're using. And this kind of open source of information actually include the name of a product, its ingredient, its recipe, and the company that is producing this. So by having all this information, we're able to actually annotate to identify the product brand involved in the recall. But is that all? No. Of course, we have to know the date. It's pretty much straightforward. When did this recall take place? And that's just a quick overview. This is done pretty straightforward. It's just by taking into account the specificities of each source, where the date usually resides in, we're pretty much pretty straightforward able to identify this. And the final piece of information that is important for us is the origin. So where did the ingredient that was recalled or the product brand that was recalled, where did it originate from? And this can come from various sources. Of course, the official source, the official data source of information may include this kind of data, so it may say directly that the country of origin was a specific country, or we are able to backtrack this information by taking into account the open data we have already harvested. So where, for instance, does a specific company import its raw materials from, or where is this source of information that we're currently processing, where it's based. Okay, so we've identified the important terms. Okay, we've talked about it. Time to do the actual enrichment. And again, we have our food safety sources. There are specificities throughout. We have identified we know what we want to identify. We know how to do this. So let's go on and do this. However, there is a small problem here that each source it's usually in the official language of the respective country. So as you can see here, we have a huge variety of languages out there. Usually, it's the official language of the country that the food authority is based in. So we have to go back a bit, and in order to do the actual translation, the actual enrichment, we have to first translate our data. And how we're able to do this? Let's add the second step into our data platform. We'll add a project, a Java project, that is the actual enrichment, that takes care of this enrichment functionalities, the translation in this case. And in order to perform the actual translation, we're utilizing an external service, Yandex in this case. So we get the data transformed into our internal schema from the AK transformer, and then we send them over to Yandex and say, okay, can you please translate this to English so we can perform the enrichment? And now we're able to actually enrich our data. And how we're going to do this? We'll add a couple of more steps into our enrichment data layers. First of all, we have three dedicated Elasticsearch instances for this. They are used actually to perform the text mining on top. So we have the raw data, the raw text that is collected from the official source of information. We are sending it over to Elasticsearch and we're saying, okay, we've integrated into Elasticsearch our vocabularies, the multilingual names, the alternative names that each term may appear, and say, okay, this piece of text, does it contain any known terms to Elasticsearch? If yes, perfect, we have identified this. But there are cases that this is not possible, so we have to add a couple of more steps into this enrichment data layer. And we're also, as you can see here, we're also utilizing machine learning and deep learning techniques. Scikit-learn is one, and Keras models are another. So in this way, we make the compact enrichment data layer wrapped up, of course, the respective API endpoints. And this way, if one fails, we can switch over to the next and be as certain as we can as far as the enrichment is concerned. So we can know which the product or hazard most probably is in each recall. Okay, so we have identified our source of information. Uh, for food recalls, we have identified the important terms, we have translated where necessary, we have enriched the data as far as it goes, but is this all? And the answer is obviously no, because within the food safety sector, the food safety sector has actually some very distinct characteristics, and uh, these distinct characteristics actually involve a vast variety of other data. Food records is one source of information, but other data may come in and prove useful to this. And just to give a quick overview, here is a list of the other data types that we're currently collecting. We have laboratory testing results. These are laboratory tests performed by countries, by food safety authorities throughout the world. These are not food recalls, these are lab tests, and they are performed by each country. We have country indicators showing the risk or the corruption index of a country. Of course, production and trade data, how much of its ingredient, of its commodity, is each country producing, or is each country exporting or importing. We can integrate companies' data. As we saw before, the food companies is an important aspect of the work that we do. So information about this is always useful. And again, we have price, news, social media, legislation, and so on. And just to give you again some statistics on this, and so that you can understand, so that you can better understand the importance of these different data types, is that as you can see here, they play a huge role. There are a huge number of data records out there for these data types. For instance, as you can see, the laboratory testing results that we've integrated so far is roughly 200 million. Trade data is also a huge data set that's constantly announced. But then again, of course, the inspection data, for instance, or the social media news also play an important role. So we've actually, at this step, we have identified more data, and some of this data are text, but there are also others that are numeric data. We have identified trade data, for instance. This is numeric data, so we need to make our data platform capable of handling numeric data, and to that end, we've added a couple of Cassandra nodes for this, and we have expanded our raw data persistence layer with two Cassandra nodes, which are dedicated to storing the numerical data as harvested by our crawling layer. Just to give again a quick overview, at its current state, our data platform has collected roughly 600 million different data records, collected and processed them throughout the years that it's been operation. Okay, so we have collected all this data, but what about the quality? How how can we ensure that all this data is actually um, cover some quality aspects and can be presented to our end users so that they can make use of this? In order to do this, we add another layer over to our data platform. This is the curation layer. This is currently a CMS system, Drupal more specifically, and this is the place where all of the food recalls end up, and some other data types, but let's focus on food recalls for now. So this is the layer where all of the work performed by our machine processes, both of the enrichment step and at the raw transformer step, they are sent over to our curation layer, so a human expert can actually review this information and says that, okay, the machine, the automatic annotation, the automatic enrichment performed by Agronow's data platform was correct, so this recall is ready to go. We'll see later on where will this go. Or perhaps our models, our text classification models or text mining did not go very well, and then the human curator, the human expert, actually dives in and says that, okay, this recall was not about, for instance, hamburger buns, but was about chicken. And he can correct it and send it over to the next layer. And the next layer, of course, has to do with data availability. We have collected all this data, we have enriched this data, translated it, perhaps humanly curated. We have to make it available to our end users. And how we're able to do this? Now, this is one of the most important parts of architecture. Of course, the end user facing layer is our data API, this Spring Boot application, and that mainly queries our Elasticsearch indexes, Elasticsearch instances dedicated to our production ready data. So we have dedicated instances for this, where all of our data, where all of the 600 million data reside. and it's where our data API looks for any kind of request that it gets. However, this is not all, because as you will see later on, we're also making it possible for end users to perform some kind of complex queries, complex search queries on top of our data. And to do that, we've added an NLP and analytics data layer that actually consists of an Elasticsearch instance for translation data and multilingual labels. We have Python scripts there that can perform NER and NLP tasks. And finally, we have a Neo4j instance, as you saw before, at the image that identifies and gives to the end user the relationships of the companies. But you will see how we're utilizing this later on. Okay, so we've made our data available, but let's dive into some more stats. As you can see, throughout our application, there were various layers that were saying wrapper APIs and data API, and this is an API, and another thing is an API. And actually, everything throughout our data platform is our API. So throughout, we're talking with APIs, and this is just to give you a quick overview. As far as the requests per year on our front end, let's say facing API, our data API is processing. So roughly, we are processing at its current state 15 million requests per year, and this is just handled by our data API. And I'm pretty sure that anyone in the audience that performs some kind of user clustering or this kind of data processing of data is currently thinking that, okay, you have so much data. Are you doing anything with it? Are you performing any kind of personalization or user profiling? You have so much data, you have to do something. Of course, the answer is yes, and in order to do this, we're adding another layer into our data platform. And this, as we call it, the intelligence layer. The main storage engine there is again Elasticsearch, another Elasticsearch instance. It actually consists of various Django apps in this case, and this layer is the one that takes into account the search requests performed over to our data API, performs user clustering, and is able to, for instance, send personalized emails or suggest things to end users, or just used by us internally in order to, to better serve our end users. Okay, and now we talked about the requests that we perform throughout our system with our data API facing. But as we said, this is a data platform that focuses that is built using the microservice architecture. So as you can see, there are various API endpoints throughout this. So more specifically, we have 130 different API endpoints, and pretty much every DevOps savvy person in the audience right now is thinking that, okay, this is a nightmare for every DevOps guy. So how are you tracking the uptime? How can you make sure that each of these components, each of these API endpoints is performing well, or is even responding? Is it up? Is it down? What's going on? In order to do this, we have another layer. We have a dedicated monitoring layer with, again, its dedicated Elasticsearch instance, and we're also utilizing Heartbeat and APM supplied by Elastic in order to do this. And all of this is integrated throughout all of our API projects. And again, you can understand that the Heartbeat is there so that we know that each port on each of our servers that is serving some kind of API endpoint that is of use to us is up and it's responding within a normal time. Okay, we've talked about how we get the data, how we transform them or enrich them. We've integrated into the curation layer, we've made them public with the data API, we've done some intelligent stuff, and we also keep track of what is going on in terms of downtime or uptime. But how is this all orchestrated? Again, let's add another layer in our data platform, and this is the orchestration layer. This is currently consists mostly of cron jobs and Airflow instances that we're currently in the process of migrating all our cron jobs into this Airflow instance. And this is the layer that makes sure that every 5 minutes we're querying the data source that we want to get the data from. And each of these steps performs well and the data end up into our data API. However, okay, we've covered all of our data platform in a second, but why are we doing all this? Why we as Agroknow are went into all this trouble to collect all this data, do all this tech stuff, and why are we doing this? This is because of Fudakai, and Fudakai is our data product. It's a data product that helps the food industry perform data-informed decisions in order to minimize food safety risks. And in order to better visualize the end use for this data platform, we just quickly show a couple of features for our data product. First of all, we're giving our users the ability to search. Now, as you can see, this is a Google-like search, and each term sent there, you can visualize that it queries the respective analyzed fields of Elasticsearch, which is our backbone for our data API. There are advanced filters, the respective drop-downs where you can select specific terms and so on. You can also perform analysis for specific ingredients or for specific products throughout our product and hazard taxonomy. Again, you can see here Elasticsearch aggregation coming into play, both in terms of terms as far as data histograms are concerned, of course. Then again, if we have this, we're also able to give the ability to our end users to make specific reports for ingredients, for hazards, for countries, and so on. And now, as far as our food companies' data are concerned, here you can see the details as aggregated by our data platform for a specific company. And you can see here, apart from the raw data, inspections, recalls, board rejections, and so on that we collect, you can see here also some other things that come into play. For instance, where this company is based in, a list of subsidiaries, main ingredients of use, and so on. Again, we talked about minimizing food safety risks, so we have to have something about the risk, and by aggregating all this data going back 40 years, we're able to do with an algorithm developed within Agroknow, we're able to perform risk assessment. So how risky is a product recipe? In this case, I have created a sesame bar that contains some raw ingredients, and here you can see a quick overview as far as its risk assessment, risk score is concerned. And again, you can understand that this data is coming out of our data API, which is querying our Elasticsearch instances. We perform the analysis on top, and our end users are able to see the actual values there. And finally, and this is something that we're currently in the process of developing, it's actually currently in our alpha version, is that, okay, we have collected all this data going back various years, many years. Are we able to use this data in order to attempt to predict what will happen in the future? And this is something that we're currently working on, by taking into account the last 40 years of data. We're trying to attempt what will happen over the next year as far as food safety and the food supply chain is concerned. And before closing, some final information here. What we've discussed throughout this webinar at this stage, that Agroknow's data platform is actually awarded by Elasticsearch for its use for Elasticsearch last year. And actually, this is it from me. Thank you very much for your attention.